Hi everyone, Victor here again. And in today's lesson, we're going to continue with the part 2 of how to deploy a self-managed Kubernetes cluster on Ubuntu Linux. If you're using an infrastructure as a service cloud platform, be it Azure, GCP, AWS, OCI, as far as you're going to be provisioning virtual machines, it's also the same steps. It's the same process that you're going to use as well. So in the part 1 of this lesson, we deployed the Kubernetes cluster manually. And in part 2, we're going to be looking at how to automate this deployment. So we're going to be using both Terraform and Ansible. And this lesson is going to be more like a 2-in-1 class whereby if you just want to learn how to use Terraform to deploy virtual machines on VMware, vCenter, vSphere platform, right? You can also, watch this video. That's the first thing that we're going to be doing. We have 5 virtual machines that we're meant to deploy. So if you look at this deployment topology, we're going to be deploying 5 virtual machines, 1 load balancer, 2 master nodes, and 2 worker nodes. And the load balancer is going to be placed in front of both master nodes so that whenever you need to communicate with the Kubernetes API server, you can go in through the load balancer. So it's the same topology as the part 1 of this lesson. It's the same thing. The IP addresses are the same thing. And in the part 1, you looked at the fact that we needed to open up some ports. For the load balancer, you open up port 6443 and 8404. For all the Kubernetes nodes, these are the ports that you're going to open. And for the master nodes only, these are the ports that you're going to open. And the reason why you're going to be opening those ports are also stated here in this article. So I'm going to be posting this article or this document URL in the description box below so that you can also go through this as well. All the playbooks, all the Terraform scripts, everything is going to be here on the website. So if you look at the steps we took in part 1, we configured HA proxy server and then we started with the step-by-step guide, which and also we allowed the necessary port on the firewall, and then we started with the step-by-step guide, which step 1 was to disable swap, and for step 2 we ensured that the necessary kernel modules are loaded at boot time for Kubernetes. So for this automation process too, that's the same thing. We're going to adopt the same method. I'm doing that because I want you to know that it's the same thing, right? And as a matter of fact, before you can automate, you need to know how to do that thing you want to automate manually so that when you eat a snack, you know how to, wiggle your way out of the problems you find yourself. And I tell you, it took some time for me to, come up with this playbook because I ran into some issues, and because I understood the manual process, I was able to find my way around automating it even when I ran into those issues. You're also going to be seeing those issues, as we go on in this lesson. All right, here's my Terraform script, and I must say this. I need to say this. I'm a bit pained, and that's because I have actually done this video before. At the point of exporting the video after editing it, I had to take out the sensitive information out of the video. And at the point of exporting the video, the application I used asked me to pay because of the kind of features I used. I actually wanted to pay, right? And there were bank issues here and there, and I couldn't use that application any longer. And I had to do this video again. So I've put in a lot of effort in this video, and that's why I'm pleading that if you're watching, please subscribe, like, share, comment. When you do this, you're going to encourage us to do more of these videos. Alright, so here's my Terraform script. You can see here on the script I have 5 main files, which are the main.tf file, main.tf output, providers, Terraform, and variables. Those are the 5 main files. And let's start with the main.tf file. So for my main.tf file, and of course the directory is called Linux VM count. So if you look at my main.tf file, this script is very reusable. I took out my time to write this script, so you can use it as a template. It works for any environment, because here on the main.tf file you don't need to edit anything. Don't touch anything here, except maybe you want to customize more in your environment. So if you look at this main.tf file, it is well customized and it's fine, so you don't need to touch anything here. On output.tf file, you don't need to touch anything even on output.tf file. On output.tf file, it's fine. It's going to show you the output of your VMs. On provider.tf file, you don't even need to touch anything. So this is your vCenter provider. On variables.tf file as well, you don't need to touch anything. In fact, that's how I really love this script. You don't even need to touch anything here, even in variables. So what you would need to edit anything will be on terraform.tf file. So on this file, or in this file, right, you're going to have your vCenter username. So whichever username that can perform any operation you want to do on vCenter, for example, or as we want to do here, which is provisioning of virtual machines. So that's going to be the username that's going to be here. So this is not what I'm going to use, right? When I want to deploy, I would have to cover this part, but I'm just showing you that this is what you need, in your environment. And for the password, that's going to be John Bull's password. For the vCenter, this is going to be the vCenter FQDN or IP address. For the data center, your vCenter data center, if you're using a resource pool, this is going to be your resource pool. If you're not using a resource pool, you don't need to use this parameter. For your data store, where you want to provision the VM, your network, the network you want to give the VM, and most importantly, the template name. So you need to have a template or even a virtual machine. You can provision a VM from a VM, or a VM from a virtual machine. What am I saying? You can provision a VM from a template or a VM from a VM, but it is always recommended, and it's a better idea, and it's also very, very fast if you provision a VM from a template, which is what we're going to be doing, right? So I have a template called this name, and everything I want in that template is there. So you would also need to have your own template, and this is the DNS server, and these are the VM list. So for the first VM, this is the name of the VM, this is the IP address of the VM, netmask, gateway, CPU, memory. Memory is an MB, megabyte, so meaning that this VM is going to be having 8 GB, right? 8 GB size of memory. Disk size is 100 GB. Firmware EFI. So for the second, for the first master node, right? This is the IP address. It's the same information. So even this firmware, I could have actually put it here, since the firmware I'm using for all the VMs are EFI. So if you want to provision 1 million VMs, just add them here. And if you want to provision 1 VM, just take out these ones or just comment them here, and you're fine, you're good to go. So for VM1, VM2, VM3, VM4, VM5, this is what you need, and this is just what you're going to be touching. This is what you're going to be editing. Alright, so let's swing into action. So I'll just change this IP addresses. Like I said, I have those IP addresses configured already, and I don't want to destroy the virtual machines because I already have Kubernetes configured on it. So 243, 244, it's gonna be 245, and gonna make this 246. I'm going to make this 247. Alright, so we can begin to configure. So I can say Terraform init to initialize. Let me just drag this up. Okay, so this has been initialized, so I can see Terraform run to see what is going to happen. So I can say yes. Okay. So there's something I need to mention here. You can see that it's asking me for the vCenter server address and the vCenter password. And there are ways you can do this. So because I want it to be fully automated, I don't want to start, giving the vCenter information here. So there are two ways you can do this. You can either use a secret manager to store your platform, which is even the best way to do it, or you can, store them here as variables, as environment variables on your system. It's not advisable you do that. Like I mentioned, the recommended way is that you have a secret manager or an application, be it Azure Key Vault or any secret manager that can help you manage your secret or your sensitive information. So for me, I'm just going to use the environment variable so that we can continue. Yeah, so I have exported the environment variables. I'm going to put it on the website on how you're going to do it. It's a sensitive information, so I can't really show it here. Now we can run the Terraform apply, and that was what I was trying to, edit out of the former video. So if I say Terraform plan rather to plan this deployment and to see what is going to happen. So let's see what plan would give to us. It's trying to read the information from the platform, and you can see here the plan is saying that 5 resources are going to be added, 0 resources are going to be changed, and 0 resources is going to be destroyed. 0 to change, 0 to destroy, meaning that nothing is going to be destroyed and nothing is going to be changed. Like I used to tell my junior colleagues and my candidates, the students that I tutor, that whenever you're using Terraform, you should be very careful and always check out for what is going to be changed and what is going to be destroyed, except you really know what you're doing. Then you can bypass this step. So now that we know what is going to be added, we can then use Terraform apply. So you can say Terraform apply to enter. Yeah, so provisioning of this I can say yes, it shouldn't take more than 3 minutes. Yeah, 2 to 3 minutes we should be done with this. And now we have errors, and the error is okay. You can see what I mentioned, that I have already provisioned those VMs. Like I said, I'm just doing this video again, and it's saying that these virtual machines already exist. So what I'm going to do is to change the names of this virtual machine or virtual machines. So what I'm just doing is I'm just adding new. I'm just saying new to the names. I'm just adding new to it so that you can see what is happening here. I'm also going to destroy the virtual machines when I'm done, because I've already deployed the Kubernetes cluster on the main virtual machines. So now I can say Terraform apply again. I should have bypassed the conditional question, so I can say yes. So now it's saying that changes to the output, we're going to have 5 virtual machines are going to be deployed. I was actually expected to see this when I did Terraform plan. I was also surprised I didn't see it, not knowing that it's because, not knowing that, okay, come on guys, changes to output, so it's saying that it's going to change the former VM names from this guy to this guy. Let's be sure of what is going to happen here. Okay, nothing is going to change. Plan 5 to add, 0 to change, 0 to destroy. So nothing is going to change. This is just the output of the former information Terraform had. So I can say yes and we can apply. So you can see what is going to happen here is saying that this are the names of the virtual machines that are going to be deployed. So I can say enter, and then Terraform would provision the virtual machines for us. So I'm going to pause the video right when it's almost done. I'm going to continue because this will take about, I think, about 2 to 3 minutes. Yeah. Okay, I think one VM is complete. Okay, still creating this one. All right. And now we have our VMs, so you can see that for the virtual machines now we have the IP addresses to be 243 to 247, and for the virtual machine names we have their names to be these names, and for the power states you can see that they are powered on. So this is how you're going to use Terraform. It's very simple, and if you look at it, it didn't even take up to 2 minutes, right? I think this was done we were able to provision 5 virtual machines in 1 minute and 10 seconds. So this is my vCenter VMware vSphere platform, and you can see the former virtual machines I said I've provisioned this one, the first load balancer, the first master node, the second master node, the first worker node, and the second worker node. And you can see the new ones we just provisioned. This one, the ones I added new to, are the new ones we just provisioned. I could have shown you the whole vCenter platform, but like I mentioned, I don't have an application to filter out sensitive information. So this is what I can show you at the moment. And yeah, I don't need this virtual machine, so we've already provisioned the ones that we're going to be using for the Kubernetes cluster. And like I said, I've even done the video. The Kubernetes cluster is already deployed. So I'm just going to join that video with this or to this video. So I can just destroy this virtual machine. So I can say Terraform destroy, meaning I want to delete the virtual machines that I just created. And let's see what's gonna happen here. So it's telling me that do I want to destroy these virtual machines, and of course this are the virtual machine names, new. I don't want this virtual machines. I can say yes, and I can delete the virtual machines. So it's saying it's been destroyed. You shouldn't take time to as well to destroy the virtual machines, and then this is complete. And yeah, because I have Ansible, I cannot provision VMs and not ping them. So I'm going to be pinging the real virtual machines with Ansible, and now you can see that they are reachable. So I've been able to, redo the video that I once did, the former video. And now I just hope that I captured everything in that video here. Okay, so for those that want to know how to use Terraform to deploy virtual machines on VMware vCenter vSphere, this is where the video ends for you. And for the folks that want to see how we can deploy Kubernetes cluster using Ansible, we can continue with the video. Alright, so this is the Ansible playbook, and every steps are well written here. Okay, first let me show you the my Ansible configuration file, which is this, and this is my inventory file, right? And a very important inventory file is this. So this is to set facts. So you should also use this in your environment. And if you look at the playbook, you can see that the first thing we did was the first play is to install and configure load balancer for the Kubernetes master nodes. And this is the task. This is the task to install the HA proxy. This is the task to append the configuration file. And this is the task to restart HA proxy. This is the task to allow the necessary port on the firewall. The necessary port here, the necessary port on the firewall for the load balancer. And and this is also to prepare all master and worker nodes. This is another play. And this play would what would this do? Okay, so this is a variable, and this is a task to, I think I'll just show you from the VS Code Studio. Alright, I think it's a bit sweeter here. So you can just copy. I'm going to be posting the website link in the description box below. You can just copy it and paste it and use it in your environment. So like I was saying, this is going to, the first play is going to configure HA load balancer, and the second is going to prepare the master and worker nodes. It's going to open the necessary port, and this is the first step, which is to disable swap. So I wrote it here so that you can follow it step by step, and that was why I mentioned that you might need to go through the part 1 of this course where we install this manually, and so you can understand what we did and you are able to appreciate what has been done, right? So here you can see that the first step, disable swap, and that was what I wrote here. I said step 1 begin, step 1 end. So step 2 begin, ensure the overlay and the BRNL filter modules are loaded at boot time. Step 2 end. Step 3 begin, step 3 end, all the way down to step 14. And if you also look at the part 1, is the same thing. So I just want to follow these steps so that we can flow along. You can see here step 1, disable swap. Step 2, ensure that the necessary kernel modules are loaded at boot time. Step 3, right? So everything has been put into the playbook, and there are some things that are very important that I will need to start explaining by the time we start running the playbook. So this is the playbook, and then I'm going to go to my Ansible node. So I have the playbook copied in my Ansible node. So this is my Ansible node, right? So I can just clear this, and then I'm going to run this playbook. So I can say Ansible, I think this is so that's the file name. So I can say Ansible playbook deploy KHS. Alright, let's run this. So you can see that the first play has started, which is to configure HA proxy load balancer for the Kubernetes master node. And then it has started gathering facts for this first load balancer. node. And the first task is to install HA proxy, which has started. Wow, I've lost connectivity. Let me just try and restore connectivity. All right, connectivity is back. And now this process. So what I'm going to do is I don't want the video to be too long. So when this process is done, I'll be pausing the video in the middle. Like you all know, in my part one, in the part one, I'm lesson my internet is terrible. So definitely it's still going to be the same thing. So installing HA proxy with my internet, it's going to be terrible. It's the same thing, right? So I know yours might be faster if you have a good internet. So I'm just going to pause this video till this task is done, then I'll continue. So you can see that the installation is completed, and yeah, it has appended the configuration file, and then the HA proxy service has been restarted. Ensure UFW is installed and enabled on load balancer node. Okay, that means firewall is actually installed and enabled. Enable UFW firewall on the load balancer node. So the necessary firewalls have been enabled. The necessary ports rather. Why do I keep saying firewall? The necessary ports has been enabled. The necessary ports have been enabled on the firewall. Right, and right, okay, so this is the second play, which is prepare all master and worker nodes for Kubernetes. So it's gathering facts for all the Kubernetes nodes. And this task is to ensure that UFW is installed and enabled on all Kubernetes nodes. So, of course, it is really, because it actually comes with the Ubuntu server. UFW comes with the Ubuntu server, it's shipped with it. So it's okay for master node 1, okay for worker node 1. Okay, I think it's checking for the other two nodes. Okay for worker node 2. Then we're waiting for master node 2 as well. Okay, it's taking a bit of time. Come on. Um, let's just wait a bit. I don't want to pause the video here because I know that some tasks should also run. So when I get to where we would need to install, I can pause the video. And again, when I get to where I would need to install from GitHub, just like the issue we encountered in the first lesson, I would need to manually, put in those files here on the notes so as to bypass the internet issue. Alright, so now it's opened. It said open common Kubernetes port on all Kubernetes nodes. That has been done. Open master only port, that has been done. Disable swap done. Comment out swap done. Ensure the overlay and BRNet filter modules are put time done. Load modules immediately done. Ensure IP forwarding is enabled at the kernel level for Kubernetes done. Apply sysctl parameters immediately done. Download and install prerequisite packages done for master node 1. Well, this is a bit faster. Done for worker node 2. Okay, maybe at this point I might need to pause the video, and when it continues I'll just resume the video. Done for worker node 1. See if I can make oops. I wanted to make the screen a bit bigger, and then I don't know. Okay, so done for master node 2 as well. Okay, so this is where this is where one of the issues, which is download container D binaries. This is going to take like hours, so I'm going to up myself here. So I'm just going to push in those binaries myself to the nodes. So I'm just going to cancel this task here, and I'm going to copy in the necessary files that is going to be downloaded, right? And then we're going to continue. So I have copied in those files, so we're going to run this playbook again. Yeah, so we should see green, a lot of greens, because some things have been done, right? So I'm going to pause this video, and when I get to that particular task, right, I'm going to continue with the video. And I think it seemed to be even faster, so I can just wait. Let's see how things work here. Okay, you see, so I already copied it, and that's why it's not green, which is the download container D binaries. Alright, so it's going to extract the downloaded files, generate download run C binary. I also copied that here too as well. Create download Kubernetes release key if it's not present. Add Kubernetes repository. Alright. Okay, so you can see it's checking if CRI/CTL is already installed. Okay, install Kubernetes packages tools, and it failed here. Why start? Let's see what happens here. Could not get lock var. You see, just like the same issue I had with my apt, so it's locked here, and I'm going to have to fix that manually, right? I'm gonna have to fix that manually. If you watch the part 1 of the lesson, the first lesson, we also ran into this problem. And for some reason, I don't know why I keep running into this problem. I think I'll have to look at it critically. But I just need to fix that just the same way I fixed it in the first lesson. I'm going to fix that, and then we're going to continue. Okay, so I have done apt update on all the systems. Maybe that is what we should have even done before starting this installation, right? So I've done apt update. So somewhere in the playbook before you even do anything, I forgot to mention that I have a playbook where I usually update all the VMs and then upgrade the VMs, right? So for Ubuntu Linux, you do update and you upgrade, and for Red Hat distros, you just do DNF update. So that is what we should have done. So you can just find a way to put it in your playbook. So let's see, hopefully we don't run into this error anymore. Okay, download container D binaries. Maybe I'll just pause the video, extract the downloaded container D, download container D, restart container D, download run C binary. That's been done. C, or download Kubernetes. C, install Kubernetes. Okay, this was where so we're running into this issue again. You know what? Let me just see. Let's read critically and see what's happening. So This is happening on master node 2 and worker node 1. So I think it's still the same issue. We're going to have to add a retry logic and time, and I would do this again. I think I'll just add the retry logic here, and I'll say register apt result, say until apt underscore result is succeeded, and retries this 5 times, then delay every 30 seconds delay. Okay, so I'm just going to use this. I'm going to really I've used this playbook many times, but again, let's add this to the task. So I can just say, okay, let me copy this just to be sure. Say deploy Kubernetes cluster 4. Then I can just remove this guy. And just to, well, I could have just, imported the files directly, but it's fine. I've already started doing it this way, so I'll just copy this and then to run the playbook. Again, I hope I've copied it well. Insert and just put this here. Okay. So I can just say Ansible playbook cluster 3. So let's start at this task. I don't want to start from the beginning again. So start a task. Just to install Kubernetes 2 packages -2. Okay. So hopefully we don't run into this problem anymore. Okay, it seems this is going to get installed. I'm just going to pause the video, and then when it's done, I'm going to resume the video. So it's getting installed on worker node 2 and master node 2. So we'll wait for the remaining 2 nodes. Like I mentioned, always try and update your nodes right before you start. I think that is why I've been running into these issues. I was just trying to avoid it because of my internet speed. Normally when you deploy a server, you should update and upgrade as well, right? Except there is any reason why you should not upgrade. But that is what you should normally do. I just avoided it because of my internet. So I have like I mentioned, I have a playbook that does that for me. When I'm done installing the servers, I just run a playbook that will update and then upgrade for Ubuntu distribution or Debian distribution, and for Red Hat distribution, you just do DNF updates. I can share the playbook too with you, where you can select the different kinds of the distributions you have in your environment. So that is done. Now the next task is to hold Kubernetes packages. So that has been done as well. Now, the next task is to initialize Kubernetes control plane on the first master node. So initialization is complete. You can see that this is fast. And that was because I did the same thing I did in lesson one. I just, bound everything and dumped it on the server. I didn't wait for it to download. So that's fine. It's initialized. It's okay. I think we've run. Okay, this is an error. It's ignoring. Copy this, config. This is a bit fast. Okay, so this is where you need to really understand what is happening. Like, I had to calm down to understand what was happening before I could write this playbook. You can see here, the task said here that you should wait for Tigera operator deployment to be ready. I also explained this to in lesson one. Whenever you are trying to install the Calico CNI plugin, if you're using the command line, if you're doing it manually, it's very straightforward. But if you're using Ansible, you need to understand something, which is whenever you deploy the Tiger operator, it comes with the operator pod itself and it comes with the CRDs, right? But there's a very important CRD that needs to be established with the Kubernetes API. And that's why when you see the stacks, I said wait for Calico CRDs to be established with the Kubernetes API server. If you don't wait for this guy to be established with the Kubernetes API server, and then the operator pod starts running, the next task, you're going to have a problem because it's going to complain of a particular CRD, which is the installation CRD, that it cannot be found. And that was why I had to maneuver the playbook to say, okay, you know what? Wait for this guy to be established, and when you've waited, wait for Tiger operator deployment to be ready, because if this Tiger operator pod is not ready and you go to the next task, which is to apply the custom .yaml manifest file, right, you're still going to have a problem again because your master nodes will not get ready, because these things has to be deployed systematically. So this is, okay, you see, apparently there is an error here which says Kubernetes will start deployment operator, blah blah blah, timeout. Alright, waiting for deployment. Data replicas are available. So there's a timeout. So okay, I think I'll probably need to increase the timeout because let's see what I have in the playbook. So here in the playbook, this task I did not add. It timed out, so I would need to also add retries, register it retries, and put a delay so that the playbook can be robust enough. So that's what I'm going to do here. Also, I can even see that I actually added a timeout. Really, this is it, 120 seconds. Let me increase this. Let me increase this to 200 seconds. Okay, so if you wish, you can even increase your own, more than that. Because, like I mentioned, right, that Tiger operator or Tiger operator needs to actually come back to life. I mean, it needs to be running. So you waited for 2 minutes and then, which is 120 seconds, I guess. And when it didn't run, it failed. So you can just, if you can even make it wait for 5 minutes in your own playbook, please add it. Just add it. So let's start from here, from this task. Just see, yeah, for Tiger operator to break. Let me confirm something. See, yeah, so let's just copy this guy. So you can see that sometimes you just need to check your playbook and make it very robust and prepare for these things. So we can continue running from here. Okay, waiting for Tiger, apply Calico. Wait for Calico post to be ready. Okay, you see here. Wait for Tiger operator deployment to be ready. So I guess by the time I edited the playbook and run the playbook again, the time has I know we've used about few minutes and that operator has already come up. If I run kubectl get port on that master node, I will see that the operator is up. So now this is applying the Calico custom resources on which it has been done. And now I also need to wait for those Calico. So again, I'm going to explain here why I needed to wait for those Calico posts to be ready. It's the same thing I explained in lesson 1, and that's because after this task, we will now need to join the second master node to the cluster. And for us to be able to join into the cluster, we need Calico to be ready, and for the core DNS ports to to change from the pending state to the running state, the Calico CNI needs to be fully implemented. And now that's why we're waiting for Calico post to be ready before we now join the second master node to the cluster. So I'll just pause this video while we wait for this pod to be ready. Alright, so the Calico pods are ready now. Joining additional control plane. Okay, we've hit another snag. The task includes an option with unidentified variable. The error was Ansible var host object, right? Line 483 column 7. So let's see what could be happening in line 483. So what I've done here, I quickly checked ChatGPT to see what could be going wrong. I didn't see anything that is wrong, right? And then, but ChatGPT just suggested that I had delegate facts true so that my variables doesn't get lost when it's being generated. So let's just try it. Okay, so I will just start from, okay, so my variable doesn't get lost. Maybe we should just run the playbook again so that it will get to the point where it starts to generate. So I think I will just run the full playbook again. Let's see. The funny thing is, have you used this playbook to deploy Kubernetes cluster no more than one or twice, and at this point we are eating this error. Okay, let's see how it goes. So I'm going to pause the video when it gets to that particular point. I'm going to play it. Alright, so we're already there. Joined the second master node to the cluster. That's been joined. And joined the two worker nodes to the cluster. So that has been joined. And we've been able to successfully automate the deployment of Kubernetes cluster. So I'm going to be logging in into the master node 1 and we're going to confirm that. So you can see that just what I added, just that one line, we're able to pass this error. And I tell you that I've learned something today. I don't know about that before. I don't know that I actually need to hold those variables sometimes so that I can use them to be able to join the other Kubernetes nodes. And today, both you and I will learn that. So now let's log into. Let me log into master node 1 or master node 2, anyone. Okay, so this is master node 1. I can then do kubectl get ports, get nodes. Okay, so worker node 2 is not ready yet. I believe that it's still initializing. So you can see that some containers are still creating. So yeah, you can see the number of pods that are running. These are the same thing we looked at when we deployed it manually in the first lesson. So let's see if they are done now. So some containers are still creating. If I do get nodes, worker node 2 isn't ready yet. So we're just going to wait for worker node 2 to be ready, and then we're going to call it a day. Like I mentioned, if you can also, integrate this into a CI/CD platform, I'm going to do that, but I don't know when I'm going to do that. But if you can do that, just you can share your scripts, you can share your manifest file. Let's see how you were able to do that, in the comment section or on the website, and so that we can also, learn from you as well. So let's check now. Get nodes, so you can now see that the 4 nodes are ready, and if I do this, all the containers are ready.